Okay, we're going to look at number 4 here. It says the Martian moon, Deimos, has a mass of 2.4 times 10 to the 15th kilograms and an average radius of 6.4 kilometers. What is the acceleration of gravity at its surface? So this is asking us to find little g on that moon. Remember, little g is dependent upon where you are. On Earth, little g is 9.8 meters per second squared. That's not the case on an object or a planet like this moon that has a smaller mass. So let's talk about how we would find that out. Alright, what I'm going to do is talk about this is my moon, and it has a radius, and if I have some object sitting here on the surface of that thing, its weight, its force of gravity, is its mass times the acceleration due to gravity on that planet. Okay? Well, the force of gravity between this ball and that is also equal to big G times m1 times m2 divided by d squared. Since both of these are mg, or sorry, fg, then these two equations are equal to each other. So m times g is equal to big G times m1 times m2 divided by d squared. Now in this case, m1 is representing the mass of this object. So I'm going to label this m1, m1, m1. m2 is the mass of this big huge planet. So if I'm solving for little g, I simply divide both sides by m1. And you'll notice that little g now equals, because my m1s will cancel, big G times m2, which is the mass of the planet or the moon, divided by d squared. In this case, d is the radius. So that means little g is 6.67 times 10 to the negative 11th newtons times meters squared per kilogram squared. That's big G, times the mass of the moon is 2.4 times 10 to the 15th kilograms, and I'm going to divide that by the distance, and it said 6.4 kilometers, so that would be 6.4 times 10 to the third meters squared, because a kilometer is 1,000 meters, so I multiplied by 10 to the third. So that means little g on this planet is 6.67 times 10 to the negative 11th times 2.4 times 10 to the 15th divided by 6.4 times 10 to the third equals 25.0125, and that's a constant, two significant figures, so little g is 25 meters per second squared on that moon. And it kind of makes sense because you're much closer to the center, so your distance is a lot smaller. So since your distance is a lot smaller, you're going to have a much greater force of gravity, and so therefore you will have a much greater acceleration due to gravity.